Okay, so I'm going to start with problem number 22, and I'm going to use an ugly gold color. So g of x equals the integral from 1 to x, of 100 times t squared minus 3t plus 2 e to the negative t squared dt. I'm running out of room here. Okay, so which of the following statements about g must be true? So it's increasing in the interval between 1 and 2. Okay, so this is how you have to think about it. If g is increasing, then g prime is greater than 0. So remember those rules from curve sketching. So when is g prime greater than 0 is the question. Okay, so if you add a prime to each side of this thing up here, then it's just the second fundamental theorem of calculus, and you'll get that g prime of x equals 100, x squared minus 3x plus 2 e to the negative x squared. Because what I did was I took this x up here and I put it in wherever there was a t. Okay, so when is this function here going to be greater than 0? So I just put that in my calculator. I went into y equals, and I put this thing in there, and then you just look at the calculator, and you're looking only between 1 and 2 because it asked only in the window 1, 2. So I set the window from 1 to 2, and I looked to see if it was greater than 0 there, and it was not. So therefore, 1 is incorrect. Okay, so now the next one says that it's increasing on 2, 3. So it's the exact same thing, but now you have to look in the window from 2, 3. So you set your window on the calculator going from 2 to 3, and you'll see that it is greater than 0. So therefore, number 2 is true. And then the third one says that g of 3 will be greater than 0. Okay, so g of 3. I need to make some room here. I don't know how to use the eraser yet, so I have to do this backwards weird thing. It's annoying. Oh, look at that. It's pretty cool. Okay, so I'm looking for, and I gotta get rid of this ugly brown color, it's disgusting. I'll take this nice mint green. Okay, so I'm looking for g of 3. So g of 3 is the integral from 1 to 3 of this crazy function. Okay, so you're going to use your Math 9. So you're going to do Math 9 in the calculator, and you're going to get function integral, something like that. And then you're going to put your function, so this whole piece here is going to go there. And then you can do comma, x, comma, 1, comma, 3. Close that. And you should get negative 1.9. Make sure that you're really careful with your parentheses. You're going to have to, when you do this part right here on the calculator, it's going to look like this. E to the, and then it automatically puts parentheses, and then you're going to put negative x squared and close those parentheses. Okay, so in any case, you should get negative 1.9, and it for choice 3, so we said choice 1 was no, choice 2 was good, and choice 3 is saying g of 3 is greater than 0. And so g of 3 is not greater than 0 because g of 3 is negative 1.9. So 3 is no good. So only 2 works, and that was choice B. Okay, so now we're going to move on to number 15 with this picture, and they're telling you it's 4 semicircles, so you don't have to worry about are they circles or are they aren't. This would be a non-calculator question, and so you're being given this function. And you're being asked, when will G be non-negative? So the question is, when is G positive? I don't know why they can't just say that. Okay, so G will be positive. Well, there's 2 different ways you can think about this, because my first thing was I was thinking, okay, G is positive when G prime is increasing, right? Because if G prime is increasing, but that didn't work because that didn't make any sense. I was confusing that with the other one. I'm sorry, I'm like reading a million notes while I'm trying to do this. Okay, so if G is increasing, then G prime would have to be positive or greater than 0. That has nothing to do with when is G positive. So then I was thinking, okay, so what is G? G is just this thing over here. This is G. And what does that mean? That's just the area under the curve. So the question is, when is the area positive? That's really what it's asking. So if you look at the picture, it's only going to be positive when it's greater than 0. So that's going to be this piece here and this piece here. Okay, so what are those intervals? Those intervals are from -3 to -2, and then the other interval is from 0 to 2. And so that is this right here, choice B. Okay, so that was a little bit tricky because it was so obvious that it's hard to even see it. So they're really testing you on understanding, well, what is G? And G is this integral over here. And then when is that going to be positive? It's when you're above the axes. Okay, so that's it for number 15. Okay, for this question, you need to find dy dx. So they gave you that y equals this. So if you need to find dy dx, it's just looking for, oops, I don't know what happened there. That's just looking for y prime. Right, dy dx and y prime are the exact same thing. Okay, so the derivative of 5 is just 0. And then the derivative of the second piece would look like this. Finding it's not as easy to write on this one for some reason with this app than the others. Sorry about that. Okay, but now this is the second fundamental theorem of calculus. Okay, so now I can say that y prime just equals e to the negative 2x squared, right? I'm taking this 2x and putting it in here for the t, times the derivative of 2x, which is 2. So I'm going to put that up here. Okay, so I'm going to move up here. So y prime is equal to 2e to the negative 4x squared, because that negative was on the outside. Okay, so now I look at all my choices, and you can see that A, B, and C are out as choices. So now the second part of this is they're telling you that in the original function, either when x is 0, y is 5, or when x is 1, y equals 5. Okay, so I'm going back to my original function. Let me change colors again. Oh, here's a nice teal. Okay, and so the original says, is giving you this, y. Whoops. I don't know how much I'm loving this program. Maybe I just need time to get used to it. But okay, anyhow, so that was your y over there. So if I want to do y of 1, y of 1 would equal 5 plus the integral from 2 to 2x, but x is 1, so 2 times 1 is 2, of blah blah blah. It doesn't even matter because I know the area from 2 to 2 is just 0. So this is going to be 5 plus 0 equals 5. So when x is 1, y should be 5, and that would be this one right here, e. But the other one won't work because you can't do that without a calculator, and this would be a no calculator question. So what they're probably doing is you would probably try D first because it just comes first before the E multiple choice. You'll get stuck, and then you'll try E, and you'll see that E works. Okay, I'm going to send this one off now.